Welcome to The Explainer. Today, we're unpacking a really incredible, game-changing system called Make Way. We're going to break down exactly how proactive agentic AI is stepping up to solve a genuinely deadly real-world problem, and that is emergency traffic gridlock.
So here's our quick roadmap for The Explainer today. 1. The emergency bottleneck. 2. AI as ambient coordinator. 3. The San Francisco proof. And finally, 4. Scaling smart city mobility.
Let's dive right into Chapter 1, the emergency bottleneck.
The current way we handle emergency response actually has a pretty massive, fatal flaw. It relies entirely on localized sirens or incredibly expensive city hardware. Think of it like walking down a really crowded hallway. The reactive model, what we do now, is essentially running down that hallway shouting, "Excuse me," while everyone panics, scatters, and just bumps into each other, creating instant gridlock. Make Way, on the other hand, introduces proactive clearing. It's basically like having an ambient coordinator texting every single person in that hallway to politely step aside 3 to 5 minutes before you even arrive.
Let's look at how that actually happens in Chapter 2, AI as ambient coordinator.
Okay, so right at the absolute center of this system is the ambient route coordinator. It's powered by a Gemini 2.5 AI agent, which essentially acts as the brain of the whole operation. What it does is connect high-speed mathematical spatial data from a Python solver directly with the live routing data we all use from Google Maps. It's just a remarkably elegant hybrid architecture.
So how does this actually work in milliseconds? Well, first, the system continuously computes a 100-meter safety buffer right around the active path of the ambulance. If a civilian car is projected to cross into that buffer, boom, the system flags a conflict. Second, that ambient AI agent instantly queries live Google Maps data. And third, it dynamically redirects those civilian vehicles onto safe, efficient detours right out of the way.
Let's see it in action. Chapter 3, the San Francisco proof. The absolute most crucial takeaway here is this number, 42.4%. By utilizing this AI-driven proactive routing in San Francisco simulations, the system achieved a massive 42.4% reduction in emergency response times. And in a medical emergency, that is literally the difference between life and death. To put that into perspective, the travel time dropped from a baseline of 12.5 minutes down to just 7.2 minutes. But honestly, here is the most incredible metric, the bottleneck density. That's the peak number of vehicles blocking the emergency path. It plummeted from 12 vehicles down to an average of just half a vehicle. That is absolutely wild. When you run these simulations, you see unpredictable traffic just completely transformed. The system clears this optimized, proactively safe emergency corridor, while all the civilian vehicles are seamlessly redirected onto detours by the AI coordinator. It literally parts the sea of city traffic before the ambulance even gets there. Which brings us to our final stop. Chapter 4, Scaling Smart City Mobility. Now, the cost-benefit contrast here is massive. Make Way entirely eliminates the need for laying down expensive physical street hardware. It relies purely on scalable cloud software. By using real-time event streams, this system can take those dynamic detours and feed them directly into the consumer navigation apps that you and I are already using every single day, like Waze or Google Maps. We've seen how transforming a reactive panic into proactive coordination can drastically cut those emergency response times. And it leaves us with a really fascinating thought. If software and agentic AI can literally part the seas of city traffic to save lives, what other physical world urban gridlocks can this technology solve next? Thanks for joining me for this explainer, and keep questioning the systems around you.